Sakana AI has just redefined the boundaries of how language models learn and adapt. Their latest AI system is so advanced that it can reprogram itself in real time to tackle completely new tasks. No retraining, no additional data, just instant, on-the-spot adaptation. This marks a monumental breakthrough, all made possible by their innovative Transformer Squared model. Later in this video, we'll also dive into how DeepSeek's newest open-source model is outperforming OpenAI's flagship o1. What's astonishing, they've achieved this not with billion-dollar funding, but with a budget that's closer to the cost of a mid-range smartphone. How did they manage such a feat? Stick around, because this is the kind of innovation that's transforming the AI landscape. Let's first take a closer look at Sakana AI. This AI research lab is focused on creating nature-inspired algorithms and highly adaptable systems. Recently, they introduced a revolutionary language model called Transformer Squared. What sets it apart? Unlike traditional methods, it can learn new tasks without requiring the tedious fine-tuning process we've all come to expect. Typically, adapting a large language model, LLM, for a new task involves specialized techniques like LoRA, or low-rank adaptation. LoRA simplifies the process by tweaking only a portion of the model's parameters, saving both time and resources compared to retraining the entire model. But Sakana AI's approach takes this concept further, allowing the model to dynamically adjust its own weights in real time during inference. Think of it as a machine that tunes itself on the go whenever it encounters something new, eliminating the need for separate, resource-heavy training sessions for every unique task. So, how does Transformer Squared pull this off? In simple terms, it uses a linear algebra technique called singular value decomposition, SVD. This method breaks down the model's weight matrix into smaller components, each representing distinct skills like math, coding, or language comprehension. During training, Sakana's team develops z-vectors from these SVD components. These z-vectors act as controls, letting the model fine-tune specific skills in real time. When faced with a new prompt, the system identifies the relevant skill areas, selects the appropriate z-vectors, and applies the necessary adjustments to the base model. The result? A perfectly optimized response, generated on the spot, without requiring a traditional fine-tuning phase. This entire process is called singular value fine-tuning, or SVF for short. Sakana AI tested Transformer Squared on LLaMA3 and Mistral LLMS, comparing its performance to the standard low-RA approach. According to their blog, Transformer Squared outperformed traditional methods across a variety of tasks, including math, coding, reasoning, and visual question answering. Its ability to adjust dynamically makes it far more versatile. An added bonus? These z-vectors can even be transferred between models with similar architectures. If you've got a set of z-vectors trained on LLaMA3, there's a chance you can transfer some of that knowledge to Mistral. However, the best results come from creating fresh z-vectors for each specific model. And here's the exciting part. Sakana AI has made their code open source on GitHub, so if you're up for the challenge, you can explore it yourself. Now let's step back and look at the bigger picture. Over the past year, there's been an intense focus on improving the way large language models, LLMs, perform during inference. Whether it's expanding their memory for longer context windows or finding ways to train them with minimal extra data, the goal is clear: make these models more efficient, versatile, and practical for real-world use cases. Sakana's Transformer Squared fits right into this trend. It enables enterprise users to adapt their existing LLMs to brand new tasks quickly, cutting down on development time, costs, and the complexity of dealing with specialized data. But that's not all we're covering today. Hot on the heels of Sakana's announcement, a Chinese AI startup called DeepSeek has unveiled their latest model, DeepSeek R1. While both models are pushing the boundaries of inference time customization, DeepSeek R1 takes a slightly different approach. Where Sakana focuses on singular value decomposition and dynamic weight adjustments, DeepSeek R1 emphasizes open reasoning and robust chain-of-thought processes. DeepSeek claims their model delivers performance on par with OpenAI's o1, also known as the Frontier Reasoning LLM, while operating at a fraction of the cost, an astonishing 90 to 95% cheaper, to be precise. Let's take a closer look at how they've achieved this. DeepSeek R1 is built on a mixture of experts architecture called DeepSeek V3, and the team has made the entire model open source under an MIT license. Not only did they build R1, but they also used it to distill multiple LLaMA and QN models, dramatically enhancing their performance in specialized domains like math. For example, their QN 1.5b distillation outperformed larger models like GPT-40 and CLOD 3.5 Sonnet in specific benchmarks. To understand what distillation means here, think of it as a process where a powerful teacher model guides the training of smaller or more focused models, transferring knowledge more effectively. DeepSeek has applied this concept at scale with R1. Now let's talk about performance. R1 scored 79.8% on the AMI 2024 math tests and 97.3% on the MAF 500 benchmark, slightly edging out OpenAI O1's score of 96.4% on the same test. When it came to coding, R1 achieved a 2029 rating on Codeforces, outperforming 96.3% of human programmers. It also delivered 90.8% accuracy on the MMLU test, just a notch below O1's 91.8%. In short, R1 is achieving near parity with top-tier models across various tasks. What's truly remarkable, however, is the cost. OpenAI's O1 model comes with a hefty price tag, $15 per million input tokens and $60 per million output tokens. In stark contrast, DeepSeek R1 costs just 55 cents per million input tokens and $2.19 per million output tokens. For those with the hardware to run it locally, R1 offers a game-changing level of performance at a fraction of the price, or even free if you're just experimenting. This cost efficiency is rewriting the rules for what's possible in the AI space. DeepSeek even offers an API for direct integration, or you can download the model weights from Hugging Face and run it yourself. They've also introduced a feature called DeepThink on their chat platform, which serves as an alternative to ChatGPT. It's fascinating to see how much progress has been made in the open-source AI space in just a year or two. But how exactly did DeepSeek build R1? It's an evolution of their earlier system, DeepSeek R 1.0, which was trained entirely with reinforcement learning, RL, and no supervised data. This zero-stage model developed advanced reasoning abilities by learning through trial and error. Over thousands of RL steps, it drastically improved performance on tasks like AIME 2024, increasing its pass-at-1 accuracy from 15.6% to 71%. With majority voting, that figure climbed even higher to 86.7%. However, there was a catch. While the model excelled at problem-solving, its language output was messy, sometimes mixing languages or generating text that was difficult to understand. To address this, the team implemented a multi-stage training approach. They combined supervised fine-tuning, SFT, with reinforcement learning, which cleaned up the text output without compromising the model's reasoning capabilities. By the end of this process, they had created DeepSeek R1, a model that matches OpenAI's O1 across multiple benchmarks. When comparing Sakana's Transformer Squared and DeepSeek R1, it's clear that AI is rapidly moving toward models that adapt instantly without the need for costly retraining. Transformer Squared fine-tunes weight components dynamically during inference, while DeepSeek R1 uses trial-and-error learning to excel in advanced reasoning. Both approaches reduce costs and enhance flexibility. With other players like Google's Titans also pushing adaptive AI, we're moving towards systems that can evolve and expand their knowledge in real time. Whether it's Sakana's open-source Transformer Squared on GitHub or DeepSeek R1 on Hugging Face, there's never been a better time for developers to dive in and innovate. These advancements aren't just incremental improvements, they're laying the foundation for smarter, more accessible AI. If you found this breakdown insightful, don't forget to subscribe and share your thoughts in the comments. Let me know what you think about these groundbreaking developments in AI. Thanks for watching, and I'll see you in the next one.